Hey guys, today we will be discussing a new topic about which is called rotation. So this in this particular game, what we will be doing is, so consider this particular game, and once our the player our player will go through the surface, or skate through the uh, skate through the hill. Then in that case, when he is in air, he has to rotate, and we will count the number of flip, and then after completion, after going reaching the finish line, we will be saying that we have taken these many flips. So for that, and let's run this. So we can see, so yeah, so see that two flips we have taken, and here we can see again taken one flip. Yeah, so based on this one, so how it rotates basically. So that is the thing. So we will be discussing this particular functionality. We can do this very easily. So what we have to do is that we have to take our rigid body 2D from the dyno, rigid body 2D from the player, get component. We are writing the script into player controller, and player controller is the dyno which is skating. So we have to get the dyno rigid body, and after that we can add a torque. Torque is basically a force which helps in rotation. So torque amount is anything, so which we can configure into our game. So for now I have taken 10. If you want more force, then we can adjust likewise. So deno rigid body dot add torque minus 10 torque amount, deno rigid body add torque amount. So this is, and how we are doing. So move vector dot x is greater than 0. So when we press our right key, then it is moving to the, so when we go to the console, we can, whenever we have pressed the right key, whenever we have pressed the left key, so our input system, we have seen a you know one. Yeah, so whenever we have pressed the right key, so we have seen 1. So it is greater than 1, less than 1, minus 1. So based on this one, we are basically, if it is motor.x is 1, then in that case this thing, if motor.x is minus 1, then we have to add a torque amount of minus 1. So this is how it is. And guys, so one important concept is, while doing this, we will find certain small factors as well. So which is, when we go to our node time, yeah, so there is called angular damping, which is for the rigid body. So rigid body angular damping is like the friction in the air. So how this particular object will, how much friction he will face, kind of a buoyant force he will face in the air, how much laterally, not horizontal. I mean, he will face horizontally, not vertically. So when he is going, so how much horizontal force he will be facing, the friction he is facing. So suppose someone is moving, when you are riding a bike, the air is passing through you, passing across, you are facing air. So how much friction, how much pressure you are going. So if we increase it, then it will move better. I mean, it will rotate in a better way. Otherwise, if it is very less, then in that case you are facing less friction from the air, and then when the skaters do, they face a huge pressure from air on their face or on their body. Otherwise they will rotate so many times, it will become very difficult to balance them. So this is how it is. Gravity scale is the gravity which they will be facing, 2x 1x, based on how it suits in your game. You can increase, decrease it. So these are the small things which I have done. And the collision detection is continuous. We haven't made it discrete, because when you see the train, they are the train is like, you can get into this particular thing, this particular, if it is with a high speed, he will get into this. So So in order to stop it from getting into that, we have made it continuous. So I hope every concept is very very crystal clear. I mean, will be very easy to understand and clear. And once the game is complete, I will redo the whole game so that you guys can do it from the start. And please subscribe, like, share our video and channel so that we can it will give me some more motivation to create more videos, more projects. Thanks a lot. Thank you very much.